Hey, good morning, everyone. It's me, Yuri, again, and we're gonna code something with the three.js and JLSL today. Let me know if the sound is good, everything is cool. I'll open up my Prosecco meanwhile, and we're gonna start coding something. Oh, morning to Brazil too, and France. There's some Prosecco, pretty cold. All right, so I hope everything is good. So today I'm gonna try to replicate this effect from the Illusion code. I think it's one of the coolest creative agencies like out there in the wild, because of the like Eden Kwan is the main person behind this agency, I believe, and he's really cool and he has got so much experience with that thing from Flash era. So it's like more experience than I have with HTML and CSS. Okay, sound and video is good. So we're gonna try to do this one. Not 100%, I think, because it's pretty complicated and involves a couple of complicated parts, but let's try to do something. Maybe we will achieve something similar or cool. Let's try to do that. All right. So I'm gonna get started. I'm gonna close some windows. Don't really need. All right. I'm gonna create a folder. I'm gonna call this one Illusion. Okay, I'm gonna switch the screen first, right? So you could see my screen. And I'm gonna copy paste my boilerplate, the usual stuff. So the thing is, they're using GPU calculation for the animation of the movement of those objects, which is kind of complicated to implement in one stream. So maybe like in one of the future streams, I will do that. Meanwhile, we're gonna try to do that without GPU. Oh, hello to Dublin too. All right, gotta get started. How you doing, guys? Hope you have a good morning, everyone. It's pretty cool here in Ukraine now. I mean, the spring is everywhere. Everything is blooming. Solution. Open it up. Let's do a simple window layout. Ooh. Hi to Poland too. All right. Don't think I need a lot of space for the visuals yet. Right. So where do we start? Well, first of all, if you look at those shapes and the paths that those lines are traveling, well, if you have some experience already with like creative coding, this is called the curl noise. And usually the way that you implement this kind of movement is by using the curl noise. And the curl noise is actually based on the like usual Perlin or Simplex noise or any kind of noise. I found a nice demo which is not working at the moment, but believe me, it's cool. So we could just curl noise demo. Like, there are a lot of code pens as well, I believe. It's just that doesn't really matter. Like the particles are moving with the curl noise, I believe. And then curl noise, let's say lines. And this is, by the way, I think by Eden Kwan. And there's a curl noise, a lot of curl noise techniques, and well, they look similar. Like they implement this kind of vector field, so some particles could move smoothly. So this is a 3D version of the noise function, like because usually noise function returns you just the float value, but the curl noise returns you three values, so like a three-dimensional vector, which you can use to simulate movement in a 3D space. And let's do that. So this demo actually has a JavaScript implementation of the curl noise, and let's I wonder how it's pronounced right. Curl or C-U-R-L? C-U-R-L? Alright, and so let's implement this noise. Well, the first thing we gotta notice here is that it's depending on the three-dimensional simplex noise. And for that, let's get the simplex noise npm module. So I might have copied the actual simplex implementation they used, but I think because we already have it on the npm, I wasn't able to find a nice curl noise on the npm, so that's why I'm using this one. Probably there are some, but it's just nice to use and credit someone for this, for his like efforts to re-implement this. So simplex noise is going to be simplex noise, simplex is going to be this, and then we will have this simplex noise 2D for the noise. I'm gonna replace every single one of them. Should have used search and replace. But I just like to put multiple cursors. Okay, so now we have the simplex noise 3D, we have the simplex from the simplex noise module. We kind of have the compute curl function. So I could just do something just to test this one. And let's see, I have to open my demo as well. Yeah, it's working. And then if I compute curl, yeah, I got some values like 4, 0, -8. Well, that's something. That's some numbers. And I probably need to drink a little bit of Prosecco. Yeah, hey everyone. Feels so good to get drunk in the morning. All right. So we have the curl noise. Okay. Let's leave it for a moment. The next step that I want to achieve is actually to have some tube, right? Because obviously what we're seeing here are some like thick solid tubes traveling in the space. So let's try to implement this. Oh yeah, this is because it's curly, right? Because I thought that was some acronym or something. Like, all right, yeah, that makes sense. Boom, boom, boom. We need to implement some tubes. So it's gonna be 3-tube geometry. 3-tube geometry. So for the 3-tube geometry, we actually need some curve, some path, and then we also need some like thickness, like the detailization, and all sorts of that stuff. So I'm gonna try to create this geometry, and because we will be using some really curly tubes in 3D space, I'm gonna implement the function like the get this, so just get curve. And where we start with that one. So I could just do this, like let points. So this curve is gonna be just an array of the points. So then I'm gonna have the loop. Let's say 100 points, 10. All right, let's be 10. And then points push. Zero, zero, and then like something I divided by 10. So it's gonna be just a straight line for now. So we're having an array of the dots on a z-axis. Actually, I think it's better to have them on the x-axis. Yeah, digital spaghetti, like pasta. All right, so now we have this curve function. It just gets us the straight line in the 3D space. Should be from left to right or from right to left. And now I kind of want to implement the actual object here. So instead of geometry, which is plane geometry, I'm gonna create the tube geometry. And also to get the actual path shouldn't be an array of the points. Like this one should be type curve. So I should actually run the curve, and doesn't actually already catmull curve 3, which accepts an array of points and gets me the curve object. So what I would do, I'm gonna do the let curve equals and then this get curve. So this one should be some curve now. And instead of this geometry, I'm gonna just overwrite this one. It's gonna be new 3 tube, that would be tube buffer geometry, and then this curve. Should I call it path? Probably path makes more sense. Hey, yo. Path, right. What else? Then the next value is the number of points that I'm using on my curve. So far I've been using just 10 points, but just for the future purposes I'm gonna use 100 points. Then there's a thickness of curve. They should be pretty small, I think, because my viewport is around 1, so the thickness of the curve should be real small. Then the next value is the number of edges, or what? Like the radius segments, which means the detailization of the like circular part of the tube. And then false is whether it's open or closed. Okay, that'll be false. So now we have the geometry, we have the plane, which is not the plane. That'll be just this curve, and then let's see what's gonna happen. We have some error. What the heck is happening here? So we have some mistake inside at object because something went wrong with the catmull curve probably. Okay, let's first output this one. What? Too many. Undefined. Please get curve. Because I'm not returning anything, obviously. Come on. So now it has all the points, and they are like on the z. I mean on the x-axis. I'm not sure that they removed completely geometry. I mean, the geometry object is definitely removed, but I'm not sure whether like plane geometry object is removed. Maybe it's still there because it's actually working right now, and I have the latest three.js here. So I believe only the actual geometry object has been removed so far, but probably eventually it's gonna be all buffer geometries, which is for good. All right, so now we have the curve. We should see some. Oh yeah, okay. We finally see this line, and I could do something like real dump, like the math sine 5 multiplied this. Don't ask me why 5, and it doesn't do anything because it shouldn't. So let's like switch the coordinates. I'm gonna see some sine curve, kind of a sine curve. Maybe I should multiply this 50. We're gonna see more curvy version of this one. So yeah, so we have some tube in the 3D space. Yeah, it's a tube. So we learned how to create this tube. Now we should get back to the curl function. Theme compression issue. Oh yeah, I'm sorry. Maybe I should just switch the theme. How do you switch the theme? Just the theme. Maybe a white one will be better. Maybe this one better. Just let me know. Why am I drinking in the morning? Because why not? This is exactly the answer. Okay, maybe black one is better, right? Okay, I'm gonna switch to black one for a moment. Just let me know how it looks like. Just too many things to remember. I keep forgetting about those noise issues, compression issues. All right, so we have the curl noise, we have the tubes in a 3D space. Now I have to use curl noise somehow to create this tube, not the boring sine function, but something really curly. So the way that the curl noise is usually used is not for actual coordinates, but usually to get the velocity of the some simulation thing of some physics, and then move the points according to that velocity. Oh yeah, thank you. Avocode, whoa. It's nice to have you here, guys. Been using you for years. All right. So the next thing, curl noise. Yeah, let's use the curl noise. So we need to use the velocity of the curl noise, and for this one, I'm gonna need the starting point. So let's start equals. So I'm gonna leave this part. I'm gonna leave this part of the object creation the same for now, but I'm gonna change the way I create the curve. So let's actually, I'm gonna move this start to the variable right there. So I'm gonna use this as a starting point of my curve. So later on I can create a lot of curves and they will start like in the different places. So this will get me the curve starting at the 0, 0, 0 point. And then here, right, what do I do next? First, I'm gonna push the start right to the my curve. So points, push, start. I'm not gonna change the starting point, so it's gonna be the first one. Then I will still have the loop, and I probably need some dynamic points, like another kind of point that I will change. And that current point equals start. I need to clone, because if I just set it to the start, it's not gonna work. Okay, then I have the loop. Well, 10 now doesn't look enough to me, so I will need more, like 100. And then inside this, I will, on each iteration, I will calculate the speed for my point, and I will calculate the speed or velocity for my point according to the place where this point is right now, meaning according to the current point. So this means that I'm going to calculate some kind of v, which is velocity, which is going to be the noise. It's going to be compute curl from the current point, and this one has to have like z. This is going to be the velocity. You can just output it maybe. Clone of undefined get curve. Which one is undefined? Oh yeah, because here I'm running it's without parameters. Free vector is not a constructor. Right, so these are the speeds. Because I'm calculating them on the same point 0, 0, 0, they are obviously the same. Like, this is just the function. Same input, same output. So I need to change something. I need to change this actual current point. So I'm gonna change this current point. I'm gonna add... why don't I have any autocomplete here? I think it's add scaled vector. Let's just Google that one. Yeah, it's add scaled vector. So I could add another vector, which is this v, and then I could scale it. Because this number is pretty big, if you already noticed, it's like 8, 4, and my whole screen is like 1. So I need to multiply it with something real small. I think this was the value that worked for me. And then this current point is being changed now, so I could maybe also output this point just to see how it works for me. And then the speed. All right, output something. Is it different now? It's the same, but that's because I'm outputting the current point and I'm changing it. So in the end, what I see in the console log is the same variable. So if I just maybe add the clone here, I would see the different ones. So what I would do also, I would do point push and then current, like the current state of my point. I'm gonna clone it. And this should actually show me something already, right? There's also one issue I already know is gonna happen. Like the scale of these values is pretty big, and I probably should divide with some big value here. Maybe, maybe not. Let's see. Oh, thank you. That's like, it's funny that I've been buying avocado for so long, and now you want to buy something from me. It's like, should have known that and exchanged something between each other. All right. So point, push, current point, clone. And now, well, I want to see what's inside those points, actually. Actually, I already see that. Some kind of curve. That's something. It's not like line, but that's something. So we could maybe experiment a little bit, like, let's put 600 points here. So we get some actually random 3D space curviness. And I could also increase the number of, let me move this function below my add object function. Kind of easier for me to navigate then. So probably the scale is all right. I thought the scale would be an issue, like, because I'm computing curl on the actual current point coordinates, and those might be changing a lot, but it's actually kind of nice. Looking good. So now what I could do next, I could create a lot of those curves. Actually, arrived at this point a bit faster than I thought. Oh my god, this Prosecco tastes so good. Should buy this one again. All right. So actually the code we did is pretty simple, right? We're calculating the velocity and then we move in the current point according to that velocity, just like a tiny bit in a 3D space. And then in the end, we just get some kind of 3D curve space. And then what if I create like 100 of those curves? Let's just throw some values in here. Like this should be also 600 because I have 600 points in my actual path. So I think I should have roughly the same amount of detalization on the curve. Yeah. Oh yeah, I forgot to mention, I actually have another awards course. So if you want to buy something and support me, you can go to the awards and buy my course. There are now 2 courses from me on the awards. I'll probably tell something about that in the end. All right. Now we have tube. Let's create a lot of tubes. To do that, I'm gonna go here and here create another loop. Oh no, not for each. Let's say I want to have 100 of those curves. And then on each step, I'm gonna create, like instead of just geometry, I probably should just create like geometry. I'm gonna be using the same material, which is something I want. So we have the geometry, and then like probably just the curve. And then we add in this curve. And then right now they will be starting in the same point and they will be the same because the function is like deterministic. It's going to return the same values. But what if I do something like this? And we are starting to get something that looks actually like curl noise. I mean, it's already beautiful. Well, there's no, I think there are no creative devs who haven't experimented with the curl noise at some point because, I mean, look at that. It's beautiful. We could create 1,000 of those, by the way. That'll take some time, but it'll look pretty cool. I mean, this is some randomness, but this is some beautiful randomness out there. And the beautiful thing about that one is, whoa, it's actually bigger than I expected. Whoa, this is looking like some curly thing. And then I could probably become a billionaire if I sell this as an NFT. but somehow I picked up the hard way. And the nice thing about that one is that they all starting on the same line in a 3D space, and then like they slowly getting random. And then we could actually make them like a bit less random. And to do that, or a bit more random, let's just experiment a little bit. I just like those. So what I could do here is have some kind of scale, which is equal to, let's say, 10, and then divide everything by 10. Should probably remove this 1000 from here. And then we'll have something like still random, some moire here. It's also beautiful. It's like almost like a 3D surface now. And you could actually generate 3D surfaces with the curl noise. And especially, I think if you use curl noise in the ray marching, it would be like the real 3D surface. Yeah, it's a beautiful spaghetti indeed. It's nice that I had my breakfast, so I'm not really that excited about spaghetti yet. That would get in the way. All right, now we have this spaghetti, this scale, maybe like 3. It's gonna be something in the middle. And of course, it takes some time to generate those, but once we are done with that, it's in 60 FPS. All right, so let's remove 1000. It's gonna be 100. So then what we might also do, instead of just generating them on the one line, I'm doing right now, it doesn't look good now. I'm gonna just do them in the random place. So now I have the very random values here, right? It should be something pretty random. We're getting some spaghetti now. I mean, I actually like this, the way it looks like, because if we like change the scale, it's gonna become more and more random, I think. Why have I like introduced the the scale variable but still divided something by 10? What I wanted to do is actually to divide this by scale. Yeah, so this is the values, and then if we, let's get something like 3, gonna get more and more curly there. Yeah. Oh, I'm glad you liked the first course. I hope you will like the second one. Yeah, there's gonna be a CMS, but it's gonna be the serverless CMS. It's gonna be the Jamstack. I think it's gonna be 11. I'm still thinking maybe I should. No, it's gonna be 11. Because I like 11, I like the creator of the 11, and like the community. It's a good thing. Okay, so we have some curls. All right, let's move to the next part. Now we need to do some coloring there. How do we do some coloring? We need some coloring first, and also we need the light source somewhere on the 3D space thing. So first of all, where do we start? I think we start at the making the background black. Kind of a lot of things to do, which are not related to each other directly. First of all, I'm gonna do this. Then I'm gonna go to Fragment Shader and let's do it this way. So the kind of gradient, it's already looking good. You could see the dark part is where all the lines are starting actually. And it's pretty cool. It's like a wind or something like that, which is actually the cool meaning. Yeah. And if you add some more, I need some more Prosecco. If you add some more, like say, bloom post effect, it's gonna look like $100 NFT. Trust me. All right. What's next? I need to put the light source somewhere in my scene, which I'm going to be using later on for the lighting. So I need to put the light source. To put the light source, is the best way is to do the raycasting. I'm going to create the raycast function, this raycast, and then let's get everything from the three.js directly. All right, we have the raycaster. Then I will need some object in the 3D space, which I'm going to be raycasting onto, and let plane equals. Some dubious stuff that I need to write. What goes the first? It's geometry, and it's gotta be plane 10 by 10, and then okay, we'll just spend a half an hour. We got the curl noise. We're on the shader part. I think we're on the right pace. Should be good. Glowing spaghetti. Yummy. Scene at this raycast. Just to see that it's actually there. It's working and it's very much red. Yeah, it's there. Slowly getting there. So the next step, I also want to create some green object. Green object. This one's going to be green and it's going to be sphere buffer geometry, and it's going to be a small sphere. Let's say 2020. Let's say maybe light. I'll call this one light. And yeah, obviously I need to add this one. All right, so we have the green sphere in the center. Green, so we can see this one. I'm really good in picking the nice colors here. Well, actually, like I'm gonna probably get this green and with this red, and it's gonna be like 1 minute of the efforts is gonna look much better, maybe. Yeah, I think it's not as aggressive as it used to be. All right, so we have kind of a green thing and the light source. Now I need to move this light source with my mouse. That's why I open up the raycaster part. So now I need to do the document. No, this container. I already have the DOM element, add event listener, and then some event here. And then inside this event, I'm going to calculate my mouse coordinates. Going to be this mouse. It's an event. Inner width. Okay. And then I'm going to raycast. And it's going to be this mouse, this camera. And then this raycaster should have some intersection. It's going to be this raycaster, and this got to be an array, but I don't want to all scene children. I just want my raycast plane. Oh. Raycast plane. I'm going to move here. And then probably, like, if intersect height and 0, like if we have some intersection, I'm going to output, let's say p equals intersects 0, first intersection, point. And then let's output this p. Let's see what's going to happen now. All right. What is wrong now? Oh yeah, I put all the calculation outside of the event listener. Mm. Maybe I shouldn't drink Prosecco during my streams, after all. But then again, I was sober and made a lot of mistakes too. So now we have the point in the 3D space, and I could actually do, like, simply do this. So I could do this, light, position, copy, P. Right, so now we have this thing moving in on my plane, following my mouse point. Next, what we could do next? Let's continue. We have a lot to do. So maybe next thing, while we didn't dive into the shader, haven't dived into the shader yet, I could actually implement this jumpy behavior. I really like this one. Like, oh, it's so awesome. I mean, it's even better than, like, it's even cooler than the actual shader part. So let's implement this nice thing. For this one, I will need a couple of other variables. So the thing is, it's quite easy to implement the point that is following the mouse cursor. That's usually called in inertia, or like lerping values or tweening values. So when I move my mouse, I always like tween my actual position to my mouse position, and it's gonna come to my mouse position, but a bit late. It's like I move this one comes. I move this one comes, like this. But that's not what's happening here. And with that approach, I can't actually create like this thing here. To do this one, the guys actually used a pretty nice approach. I usually use like the separate values, but I keep forgetting that three.js already has a lot of functionality implemented, like the vectors. So they're like three two-dimensional vectors are already in three.js. And this means there's like a lot of ways where you could cut the corner and like make something cool with just a couple of lines of code. And that's exactly what we're gonna do right now. So to move it step by step, I'm gonna create another mouse position. I'm gonna call this one like e-mouse. Then I'm gonna create another one. I'm gonna call this one a elastic mouse. I think that's the way they called it too. And then I need the velocity. So to implement this kind of functionality, you actually need additional like vector, which is going to be implementing the velocity. And by default, I'm not sure if three.js setting zeros for me. I'm going to set them. So I have the elastic mouse, and for now, let's also let's do it this way. Blue. Just some stuff to visualize. Where's my blue? Okay, I haven't created the DOM element. So I have this blue point, and I want this point to follow my mouse cursor with the like bouncy way. And to do this, I can create this. So I can create e mouse x equals event cloud and x. I could have probably moved right to for the 3D first, but that's just gonna try to create it with the DOM element first. So I have the e mouse position. This is gonna be like at all times the actual mouse position on my screen. And what next I will do? I will do some calculations on my render loop. So right here, first of all, I'm gonna set the coordinates of my object. So let this I'm gonna query something in the render loop. Don't do that. I'm just making something fast. I don't know, style. And then what's it gonna be? This e mouse x, and the same for the y. Okay, it's almost like it should be. It's just, it's a bit inverted in some way. Okay, so now the blue thing is following my mouse pointer, which is not quite what I need. I need it in jumpy way. So this way I'm gonna set the elastic mouse. Elastic mouse instead of mouse. I'm gonna set elastic mouse. And I'm gonna calculate this elastic mouse in some special way. So first of all, I need to calculate the velocity, like with what speed this thing should move somewhere. And to calculate this velocity, I need to get the difference between the current position and the current position of the elastic mouse, like the current mouse position and the current elastic mouse position. It should be a little bit behind at all times. And I think I'm gonna need another temporary variable here. Or maybe I could have got away with the cloning. So I'm gonna temp copy this mouse position. So now we have in this vector we have the actual mouse position. I'm gonna subtract the elastic mouse position. I'm gonna multiply this one with something small. I think this was the value that would, like, it shouldn't be like the real length of the vector connecting those 2 points. Should be a bit smaller. So this one is always a little bit behind. So the next thing, at each step, I'm gonna add this velocity, like this is the velocity that I just calculated. So at each step, I need to add this velocity to actual velocity, right? So I should change the elastic mouse velocity. And I will do it this way. I'm gonna add this temporary variable. So this way I just added something to my velocity, and then to make it stop, because this way it's gonna grow like infinitely. To make it stop, I'm gonna multiply this one, which is also known as a friction or something like that. Usually like 0.9, 0.8. I think it was 0.8, which were good for this one and the value that they used. So now we have this elastic velocity calculated, and then I just need to add this one to my actual elastic mouse position. So I'm gonna just add this elastic mouse velocity. And probably the magic should happen now. Yeah, it did. So you could, of course, change the values with these numbers, like let's say 65. It's gonna be real stiff. Or maybe like even less than that, like this. It's a different, it's more like, it's not bouncy anymore. That's not cool. It's easier to create without velocity even. But with some values in between, you get it like pretty nice, right? And in the same way, we could calculate the position of this 3D object. Let's do that. Let's do that. I believe the stream is going to be a little bit over the hour. I'm sorry, guys. It's just too cool of an animation. Too many cool stuff. Cool things about this one. All right. So we have the elastic mouse. Boom, 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 boom. What else? What else? What else? 3D object. 3D object. So I need somehow to use this elastic thing for calculating my 3D object. So I think instead of using the mouse, I would just switch back to the, where's my recasting part? Probably collapse this all. I'm gonna still use this mouse because it's, no, I'm gonna override like this mouse x equals p x, and this mouse y equals p y. This way, the values that I'm gonna get inside my elastic mouse is gonna be in its 3D space coordinates already. And instead of doing this here only in the event listener for the mouse, I'm gonna do it here. So this light position X equals this elastic mouse X. Yep, so now we have this 3D object, which is bouncy in the same way that we just had this blue square. So now we have kind of a light source. All right, let's move next. Let's move next. I should drink something. I should drink something. Just a minute of brain rest. Yeah. Hope you're following my steps. I mean, mentally, not really writing the code as chaotically as I do. All right. Next step, I need to put this light source as a uniform inside my shader. So for that one, I don't need this get curve function anymore. I need this light source, let's call it. All right, I need some dark red, like maybe this one is good. Dark red. Should I use the same shader for my plane actually? All right, let's see. The most interesting part is ahead, actually. It's actually ahead. Which one is red? Raycast plane is red. Yeah, I think it's kind of better. Need something darker. All right, and I think the sphere should be like real tiny. Okay, pretty cool. Next. Let me think. So yeah, I need to update my light uniform with the actual value. So it's going to be this material uniforms light value equals new 3. Shouldn't probably create the this point right here, but I should probably update it in my render loop actually. And actually this might simplify it because I could just set this to the light position, right? So now we have this ulight uniform value as a light position. Well, the next thing I want to do, I want to actually switch this one to this material. Yes, now we have this UV gradient on my plane. And what I want to do now, like I have this light here, and I'm going to calculate the distance between light and the current point I'm rendering, and it's going to be the length and then light minus p position, and then kind of want to output this one here. But also need v position. V position is 3-dimensional thing. And v position couldn't be v position because v position should be like in the world space coordinates, right? Or not? Okay, maybe let's try to do this one. Something is wrong, like v position. light. It's not varying, it's uniform. Right, so now we have this thing following my mouse. Perfecto. The next thing I want to calculate, like 2, 3, 5, 5 a lot of things to calculate actually. And this actually makes darker my like my lines too, my tubes too. You could see the dark when the light source getting closer to them. And we could actually invert this one, something like this, which is kind of like a volumetric lighting, I think, something like this, right? Which is already pretty cool, but that's not what we want to do, but it's actually kind of close, right? Okay, let's proceed. Let's proceed. Too much talking, Yuri. Hey, everyone. Next. I want to calculate diffusion lighting, like the simple lighting from my source of the light. Because I have the normal here, which I'm not yet using, by the way. Normal. And then here, normal. Let's just output it briefly. Yeah, normals are there. Let's calculate diffusion lighting now. That's gonna be the complicated part. It's gonna take like 10 minutes, but still. It's gonna be the max 0 dot product between the normal, and then we should calculate the dot product between normal and then the light direction. And then we have we don't have light direction yet. We only have the light position. U light is a light position. And to calculate the light direction, I would actually need to get the global space coordinate. I think I had it somewhere in the previous streams too. I think I had it on my desktop too. I'm gonna just go. It's a pretty common thing that we usually do. It's like this. I'm gonna calculate the world coordinates, position. I'll be varying, and then like the three light direction is going to be normalized, and these values subtracted, like the U light minus free world position. This is going to be the direction of the light pointing to the point in space where I'm calculating the diffusion light, and this is what I need. I'm not sure about the sign though. Probably right. Let's just see. And then we'll have this diffusion. I'll put the diffusion. Everything is broken now because 103. Oh, yeah. Calculating the dot product between normal and the light direction is going to be diffusion, right? Should be right. Yeah, we're kind of getting it. Like when the light source is from this side, you could see that it's actually lighted. When it's on the other, it's getting darker and it's lighting some other parts of my surface. I think sometimes it's just too jumpy. Yeah, so diffusion lighting is actually working. Actually, I think we could even multiply diffusion lighting with this distance variable and get some decent result, but that's not what developers of the Illusion website did. They actually used a pretty nice physics concept, light scattering, and found a pretty nice article explaining this concept. It's called A Simple Shader for Point Lights and Fog. Well, it in some way it's a simple one. And there's a real nice explanation, which I advise you to go and look for, and which ends up with some kind of integral which you need to calculate to get the actual lighting at some point. And this light scattering is actually taking into account the light fall off, and then also the light, like the angle, because it actually takes a couple of variables in here, like the light position, the camera position, the object position, and then the distance from the eye to the object, and like all the distances, and then it gets you the value. I'm gonna fast forward and use the function that the Illusion developers used, which is called getScatter, to calculate this scattering lighting thing. And let's try to use this one. So this one is taking the camera position, the direction, which is the camera to the point direction in space, the light position, which we already have, and then the distance from the light to the point we are in space, like from the... No, it's actually distance from the camera to the point. Yeah, it's distance from the camera to the point. And you could see a couple of dot products and then the subtraction of two A10s, and this is exactly what you have here. So this is just an implementation, maybe simplified for the for faster calculation, but this is just an implementation of this integral calculation of this formula. I'm not gonna dig deep into that, but I'm really curious to do that, but I'm not sure everybody is curious as me. So I'm gonna just use this function to calculate the light scattering. And I'm gonna fast forward and write the end formula, like gonna be the float value, scatter is gonna be equal this getScatter. Then the camera position, which we already have at the uniform in three.js, which is real nice. Then we need the camera to world normalized. This direction should be normalized one. And camera to world. And for this one, I need to do some calculations. So first of all, I'm going to calculate camera to world, which is going to be equal the same world position minus camera position. And then from this, we could derive both distance and the direction. So the camera to world direction is going to be just normalized value of this vector. And then the distance is going to be the length of this vector. All right, so far so good. Now we also need the light direction, which is light. Let's call this one light to world to preserve the same name structure. This is light to world. And what else we are missing here? I think we also need the normalized light to world. Like we already have the light to world is already normalized, right? Perfect. So now we could use in this formula, we could use camera to world direction. Camera to world direction is the second parameter. Then the next one is light position, which is just the uLight uniform that I already have. And then the last one is the distance to camera to world distance, which is... And this should be it. I could now output my scatter value. Have some GLSL error, dimension mismatch, 120. Oh yeah, it's not the... Obviously, it's not the three-dimensional thing anymore. And you get this. Like, you could also get this probably with move step or something, but the thing is, when we turn like this at the angle and we are looking at the angle, you could see that this light is not symmetric. It's not right. Like, I mean, it actually looks like a light, more natural. Like it's more pointing, what's that, from us than towards us. Right? And this is exactly what we need to achieve this kind of shady, foggy look, which looks nice. You could also experiment with these values, I believe, like maybe 15. It's gonna be like some brighter kind of light. So depending on the look that we want to achieve, we might change that. All right, so now we have this. What's next? Next is Prosecco, and I'm running out of my Prosecco. Yay, nice to see you live. Link to the post. Okay. Hope you like integrals as much as I do. Boo. Next, so now we have this pretty cool light scattering thing. Now I should probably combine both light and diffusion lighting, and then I will get some kind of in-between lighting. And remember that I'm not actually using the exact colors that used on this website. That's why it looks a bit different. We're getting there. I think I'm gonna live with the red, shades of red, because we're just using shades of red here. All right. What else? What else? What else? What's the next step? Combining scattering and the diffusion. So I'm gonna create the like float, the final something. It's gonna be scatter plus, but I want like when I'm using diffusion, it actually lighting everything like it's every single distance. It doesn't take distance into account, just the direction of the light. The scattering, on the other hand, has the light fall off, so the light is not going infinitely into the distance. And I want to kind of multiply the diffusion with the scattering, because this way I will get, I think something good should be getting there. Maybe it should be more complicated formula, but let's try this one first. I should use this final now. What final? Diffusion. It's not diffuse, it's diffusion. Okay, I can understand you. Okay, where is everything? Oh, it's there. It's actually there. It's just it's hard. It can hardly be seen. Okay, so let's maybe just the diffusion. Pretty cool. And then maybe like this. Maybe, yeah, maybe it was that coefficient. It just light doesn't get through. Okay, we are getting there. Still pretty dark. But what I could do here, couple of small steps left to implement this whole thing. It's already like looking cool, but not cool enough for me. Okay, let's just briefly show the scattering. I believe we should use a different coefficient for the plane and for those things, and we should render them in a couple of render loops. Okay, let's do it. Shader cubes. And create two shaders, one for the background plane and one for the tubes. Same, but different. And I'm gonna use this material for my tubes. And then I will need to update the uniform anyway. Okay, light position is being updated. I will also need to include those shaders. Tubes. Called tubes. Right, working again. And then I could probably use different numbers in both of those. So in the in my where's that? This is going to be the shader. This one probably on the tubes it should be brighter. On the tubes it should be brighter. Brighter is I think 15. So this means on the other one it should be 150. 150 here. Yeah, we're kind of getting closer to that amazing look from Delusion. Then we have this issue with the depth rendering, and then I'm gonna briefly fix that one. To collapse this one. Else. And then I'm gonna add my plane to another scene. So this raycast plane is gonna be in this scene 1, which I'm gonna render first. And then I'm gonna render all the rest. I'm just gonna go and I forgot how to write this code. I'm sorry, after an hour in Prosecco I forgot that, but let me remember how it's usually done. Some other project, you have to clear this stuff first. You have to clear this stuff first. Where's rendering happening? Here. And then I just rendering, clearing depth, and rendering again. I already did it in some of the past streams, so just it's gonna be scene 1, camera, clear depths, and then this scene and camera. Yeah, this way I'm kind of still getting that plane and my scene, but it's rendered first, and now I have this light being like real close to those lines. Why the zooming is not working? Actually getting pretty beautiful, and we have kind of like a foggy lighting, like volumetric lighting, but this is an illusion because we have this plane behind all those shapes, and it's also lighted, like this plane is lighted with my light source, and we get this nice illusion. I'm not sure if this is done exactly the way on the illusion, but probably similar. There's probably another coefficient for those lines, and then what we could also do, to the shader cubes, and then plot like tube dash equals what? Sine function from the PUV x multiplied with 5 last time, and if dash below 0, just discard. And we get this now, which is already pretty cool. Just like a wind, which we could light. So when I move the light source, it's dark, like because the light source is behind the shapes, and now it's lighted. And this is actually the only thing left here is actually why this somehow this I'm still moving something which I shouldn't move probably on the app.js. I shouldn't do this. I think that'll be better. Yeah, it was in the way. Me zooming. Yeah, this, and then maybe a lot more random and a lot more those lines. How many of them I have anyway? Like just 100. That is not nearly enough for me. I want to have a lot more. And I think I want to have them more random, and this means like this step thing should be different. Because this more random means 1 probably. Maybe that's too random. But now we get this feel. I mean, of course, the time should be divided. I mean, you could see it's pretty complicated. It's a lot of tiny details that add up to this whole beautiful look, and this is like a huge respect and to those developers that achieved this look. I'm just merely I'm just a mere mortal trying to replicate the stuff that they did. Probably slower than that, and then we have those lines, probably also like this, so we have the actual kind of tubes. Given something of this sort should be. Now we have flying tubes which are lighted, and now it's about finding the spot to like. Maybe I should do something like this, and then I think it's better. A lot of tubes flying around. And this bouncy light, yeah, I think that's it. We gotta stop somewhere. I think it looks pretty cool. We would play a lot, of course, with the all sorts of lighting, like the diffusion lighting. I think it's kind of getting lost here at some point because I multiply it with scattering, and we don't really see a lot of diffusion lighting here. Maybe we should, at some point, we should just somehow change the formula. Yeah, like right now it's more of a diffusion, then there are no scattering, but it's still kind of nice, right? Phew, it's been some journey this time, right? I think it's pretty cool. So the only thing left, of course a lot of things left, but I mean, in general, is to implement the simulation of those, of moving of those things with the GPU, like with the shader sim. And it's gonna be like kind of it. I think we got pretty close, and it's pretty cool, like when this light source is traveling there. And we haven't even used any post-processing, but it looks like it has some bloom thing there because of this background plane that I used to render first. Pretty cool, right? I think it is. I think it's pretty close. I'm always too critical of myself. Like it's not close. It's completely different. It's too simple. But I think it's, in general, this is the direction. And then, no, I don't think I'm cool enough to work for them. But yeah, it's again a big honor just to decompile their stuff, and every detail is amazing. They are really cool creative developers, especially Eden One. Just check out his work. Alrighty, yeah, I think this is it. I'm gonna finish with this animation, but I probably should mention that because I just launched the new courses, and if you want to support me, you can support me on my Patreon. And thank you everybody for supporting me on Patreon. I have the biggest support ever on Patreon at the moment. But I also have some courses on the Academy Awards, and this one is actually pretty cool. I bought this one myself by Luis Enrique Bizarro. I advise you really much of that because it's like kind of the same. We are working on the same field, and this is one of the developers I'm looking up to. He's really cool. I will create this one. It's going to be a simple WebGL portfolio website with one specific effect that I really like for the full screen image animation. And then there's another workshop by me about kind of the same thing, about merging the HTML and WebGL, but a different way, just a different it's a different thing about WebGL and HTML. So I'm gonna try to maybe create more. I'm gonna keep on streaming. I hope you like that. Let me know that in the comments. It's always really important to me, like whether it's just a smiley face or something else. Yeah, it's definitely time to update Chrome. And it's time to update my Prosecco, because I actually finished this bottle. There's no Prosecco for me anymore in this stream. So I guess I gotta finish my stream because I can't continue without Prosecco. So, cheers, guys. Say something good to someone you love. Hope you have loved ones. Call them, call your parents, do something good. This is a nice world. Spread some love. Be a good person. And hopefully see you in a week. Just read my Twitter. I always announce streams. Sometimes I can't, sometimes I can. When I can, I stream. Have a good day, guys. See you. I'm gonna stick in the chat for a couple of minutes and